Hello. In this video, we'll look into an interesting topic, which is RAG or Retrieval Augmented Generation. In a previous video, we talked a bit about vector databases. And vector databases is something which you use as part of RAG. Okay, so RAG has three parts basically. There is the retrieval part, there is the augmented part, and there's the generation part. Okay, in vector databases, we already looked a bit into the retrieval part, but it's not that simple in the case of RAG, as in we need more optimizations, as in we'll need to be very careful what we retrieve. And the second thing is the augmentation, and then third is the generation. So RAG is mainly used with large language models, right? And it is to solve an inherent limitation of large language model, which is the context length. So as I mentioned in vector databases too, large language models has a huge issue with the context length. Older models have very less context length, like maybe on the order of hundreds, and right now it has increased into the order of, let's say, 100,000. But it still is a problem. This is because, let's say, if you take an example of if it's a restaurant chatbot that you're using with a large language model, let's say it's a restaurant chatbot, and then you've been talking with it, okay? As in, you have a huge chat going on between you and the restaurant chatbot, and then you want to like come back later, you want to continue with it, but you want context from before too. That's something you have asked before that is still to be there. If you're just using a large language model, what happens is you will have to just add all of this content together into the context. So if you have a total context window of, let's say, this much, let's say 100K tokens, first what you'll do is you'll have to have this context, and as you speak it just keeps adding. And if you want to add more stuff, you'll probably have to sacrifice some of the earlier context. Moreover, if you're using a huge context window, you're going to end up using a lot of compute too. So maybe in this there is a lot of data which is relevant, maybe some part of the data is relevant, but some part of the data is not even relevant, that you don't need it, but you're still passing it to the large language model. So if you simply look at how it works, what it does is, as a user, we submit a prompt and it goes to the large language model, and the large language model creates a query. As in, it asks for more data. Let's say if you didn't have this, okay, you only have your current window. And instead of having the previous chat in, right, previous chat directly in context, what we would do is we'd query the previous chat. It'll be stored in some sort of a database. Maybe it's a vector database. And then you ask it your relevant data. Like if you're asking for something about a particular kind of dish or something like that, it'll just go back to your previous chat. And then the data source will respond to whatever is there. And then the large language model goes back to the generation part. Now it'll have something like, instead of a query of, okay, how is this dish, it augments it with an additional information of, okay, now answer this with the following information, okay? And then you provide whatever you gained. Maybe it may be like 3 sentences or very short amount of information, and you augment it with this. So now the new prompt is not just this, but along with that, we are passing this additional information that we retrieved. So with the prompt and the context, now the large language model doesn't need to go through the entire context, but rather just needs what is needed and then returns back to you. So there are a lot of optimizations possible, as in what, how do you retrieve it, and how do you augment it, how do you rank whatever data comes. All of these is very important in RAG. It's a lot of there's a lot of types of RAG too. There are things like even graph RAG, which we won't look into much detail in this video. Uh, and it is when all of the information is arranged in a graph manner, so that you can just go in between it. Like you can go to the nearest neighbor and find whatever is next. There is simple naive RAG, which is uh, just a retrieval augmented, just a retrieval, and then the generation. We'll look into that. There is more advanced techniques too. All right, let me take an example. So if you ask a query of this, okay, how do you evaluate the fact that OpenAI CEO Sam Altman went through a sudden dismissal by the board in just 3 days and then was rehired by the company, resembling a real life version of Game of Thrones in terms of power dynamics? Okay, now if you directly ask that question, that might not give you a really good answer. It'll probably say, I'm unable to provide comments on future events. This is because if you're using a model like ChatGPT, let's say 3.5 or something, it doesn't have access to whatever is coming after a certain point, right? It has a knowledge cutoff. Okay, so if this is something which happened in 2024, and if its cutoff is at 2022, it'll never have access to that unless we just provide it externally. So what we do is we have all of the necessary documents first divided into some chunks, and this is called chunking. We'll see what chunking means and how it is done later, but we just chunk all of our original data. Like earlier we said that we have some previous chats available, but we won't just pass all of it together. We'll just divide it into some sections. Maybe it is by date, maybe it's by other things. And you divide it, and then, like we talked about in the vector database video, you embed it. And just to retouch on it, and to take an example of a simple KNN based embedding, K nearest neighbors based embedding, if you have an image of a lot of fruits, and then what happens is maybe all of the apples are in one area because of clustering. It's similar, like it has similar shape, similar color, etc. And maybe a lot of the apples are together in another place, and maybe all of the oranges are in another place. And if you want to retrieve some data, you just go there and you get it back. So you have some sort of an embedding, and things which are together will be embedded together. So even if you have an MNIST data set of several numbers, in the embedding space, it's likely that similar numbers are grouped together. Okay, so you have some sort of a grouping together of similar entities. Yeah. So you have a similar grouping. You have a grouping together of similar entities. Okay, that is what is meant by the embedding. So you have embedded it, and now the retrieval. So depending on the query, let's say we asked about OpenAI, CU, Sam Altman, all of these. So these chunks are retrieved as an example. Okay, this news piece. Okay, there is this thing and this thing. All of these are retrieved. And mind you that ChatGPT, our large language model, has no access to any of this information. So once you have this ready, you feed it back here as a context. So you have all of these chunks added and also this question. So this is our new modified or augmented prompt. And with this prompt, now the LLM is capable of generating this information. This is a simple way of how an RAG works. Now there is something called fine tuning of LLMs, right? So if you have a large language model, maybe Llama 7 billion or something like that, and you want to use it for your organization or your projects, what you probably do is you'd fine tune it for your own use case. Maybe, let's say if it's a medical use case, you'd fine tune it with a lot of medical data. Okay. But the main issue here is that just like I talked before over here, there's a knowledge cutoff. Now, the large language model has a fixed context length. Let's say a fixed context length and its ability to relate between all of this data, whatever is there. So it is frozen in time with that kind of a knowledge. Okay, it's frozen at a particular place with a particular amount of knowledge, and no new knowledge will be added. So if it was at a particular state initially, you just make slight changes and then you get a new state of the large language model. Okay, it has slightly improved connections between information. It is slightly improved, but this wouldn't solve a lot of issues. Let's go back here. So also we'll look into how fine tuning works and how do you do it later on. But let's just understand that fine tuning is just changing the large language model a little bit, as in teaching it about a specific domain, right? It's tuned to a specific domain. All right. So the first thing is the external data access. Like I said, if it's frozen in time, it will never have access to any external data. Let's say if you ask what's the weather today, it will not have access to that. But at the same time, if you have an RAG system and it's linked to a weather database, then it can query that and then it can get that data back. Right. A weather database, and then it will just get the weather data back, and then you can augment it and generate it back. All right. And another thing is a frequently changing data. If something like weather, for example, or even maybe a real-time data is where people are adding more stuff, you can not use this because it keeps on changing. But an RAG doesn't is decoupled, or like is not directly connected to the large language model, so that you can have changes in the database without changing much in the large language model. Okay, you can just make changes here. So yeah, so you can keep up to date info. That is an advantage. And there is a traceability, and this is very, very important. And one thing I overlooked when I explained the necessity of RAG is hallucinations. You must have heard about this term before because it's in use a lot. Hallucinations, if you don't know, are, let's say, things generated by an LLM which doesn't really exist. So let's say if you're doing an image generation model and instead of four fingers, you have an additional finger, things like that, or maybe something like another eye or extra things which shouldn't be there. And this in the case of an image model, or if you ask for a text generation and then it just generates something saying, okay, this was talked about in this 2022 paper by Joe, and then you Google search it, a person called this Joe doesn't even exist, and this paper also doesn't exist. So the LLM is just hallucinating this. This is an inherent limitation of large language models. It's very difficult to remove it because it's like baked into it. But what we can do is we can minimize it as much as possible. So with traceability, if you use an RAG and you have, let's say, a lot of academic papers in the database, and then you ask the model to retrieve something related to, let's say, if I want to retrieve something to related to hallucinations, maybe there are few papers here which are related to hallucinations. It'll retrieve those, but then you can trace it back. It'll just tell you that it is from, okay, this is from document 3 and this is from document 1, whatever it is. And you can just go back and look it up yourselves. And same thing goes for something like weather or anything like that, maybe news articles. You can just go back and verify it. And of course, it minimizes the hallucinations because you're using factual data instead of relying on whatever is the LLM's inbuilt knowledge during training, from training with all the amount of data which we gave to it. It's not just limited to it. And if you want to completely change the model behavior, then maybe you don't want to use RAG. Let's say you want to make a large language model which is really good at talking to kids, for example. And even if you use a model like GPT-4o or so, and if you directly augment it with RAG, maybe it doesn't really help if you want to change the tone entirely, or if you want the model to be acting in a specific manner and has a fundamental change in the model itself, then that requires something like fine tuning. Earlier, I talked about some example of medical large language model, which should could be used for um, taking medical data, maybe to help doctors. Maybe there you probably need to fine tune it first to change the model behavior first, and also maybe augment it with RAG with external information too. And another thing, huge advantage about RAG is if you want to fine tune a model, you'll require a lot of new training data. But with RAG, you just need to provide some information. It's just like a lookup table where you don't know about something, you just look up Wikipedia, you just see a particular thing, and then now you know about it. You don't need to learn all of Wikipedia or like all things related to that to have an understanding of that. And of course, extending to traceability, there is also a trustable response with RAG. There are only few advantages of fine tuning compared to this, and also if you don't understand fine tuning so well, don't worry, we'll talk about that in a later video. But yeah, these are huge advantages of retrieval augmented generation. Okay, so when you're designing an RAG model, there are several parts to it, and first is the indexing. That is, if you feed a lot of data, how are you embedding it? How are you storing it into a database, right? Like, let's say it's a Pinecone based database. So, how do you process the data first? What kind of indexing do you use, and where do you create the splits? See, earlier we talked about having some kind of chunks, right? And how do you exactly split? So do you just keep some similar things together, or do you just divide it in some other manner? And this is one part of the design concerns, like how do you exactly chunking it, and how big should the chunks be, how like each part should be, so when you retrieve it, like you get a chunk back, right? So how much should this be? That is one thing which you have to tune and you have to get it right. And another thing is storing. And how are you going to store it? Like, what kind of vector database are you going to use? Are you going to use something like VV8 or ChromaDB, or maybe something like Pinecone, which we used in our previous video? We learned how to do semantic searching with Pinecone. Maybe you can use Pinecone here. So depending on your use, you'll have to choose what vector database you have and what kind of metadata is there too. Like what has to be there along with the content. Maybe something like date or anything like that. That all comes in the metadata. And the next thing is retrieval. So earlier in Pinecone, when we were doing a simple semantic search, we did a very simple thing like the highest similarity scores. Maybe something has 0.77, it's like that kind of similarity. So the highest similarity will be just ranked like top 5 with the highest similarity score. It's a direct thing. But maybe this is not always good because the similarity score is not that reliable too. Maybe uh, it works most of the times, but it's not extremely reliable when we are applying it into a system. So we probably need some kind of augmentation too in the retrieval too. So yeah, so how do you decide the top ones and how do you decide the cutoff, all of that? That is also a design choice. And the next thing is the synthesis model. And how would you synthesize this? Like, how do you generate the data? Like, how do you, what prompt do you give to the LLM back? So now you have some kind of, like, let's say we retrieved a chunk of data, and this is what we need. Maybe like top two you took, and then now what do you do with this data, right? So that comes in the synthesis part. So that is also important. And finally, you want to evaluate it. You want to see how good your model does. You won't talk about evaluation much in this. We'll try to build upon how RAG works more, but but evaluation is very important in RAG. We will try to look into evaluation in the future models when we try to build an RAG system ourselves. So stick with me for this, and then in the future we'll try to create an RAG with the code. We'll just, we'll just code an RAG system and see how it works. Okay. So I talked about chunking. So there are several strategies to chunking. One is fixed size. So if you have this external data, we have a fixed size. Let's say it all has to be in a specific day. So if you add some external data too, it will be still in the specific chunk size. So that's a fixed size, a very simple thing. There is something called recursive chunking. So if you have a lot of sentences, and maybe you have some kind of a separator, this is like a space, or maybe this is a slash n, which is like a new line character. So it just recursively keeps splitting it into several parts. That means it repeatedly it creates one split, it creates another split. Let's say it creates one split, then it creates another split. It keeps on going until your ideal chunk size is reached. So that is one way. There is document based. That means there is some characteristics of the document specifically that, let's say, some certain sections in the document are in a particular manner. And let's say if it's images, then you have um, some area in the document in a certain manner. So you divide it based on how the document is distributed. So it's not just blindly dividing the document into parts, but it has some connection with that too. Like, what is the content of the document and where is what in the document? Maybe there are some tables, there are something else. So you just have all the tables together, things like that. So it's document based. There is also semantic chunking. So depending on the context. So this is a bit more complicated than fixed size. So I'm not going to depth about any of these, but I'm just letting you know there are several ways to do this. So semantic chunking is based on an understanding of what the relative things are. There is also agentic chunking. You don't know about agentic so far, maybe, but this is something which will come up later in this course too. That we'll talk about agentic AI and what agents are really. But as a simple thing, you can think of it as you're just giving an external AI, a job of, what do you say, if you have a lot of things, let's say if you have this data, this AI will decide how to do the chunking, and this AI is just specialized to just do the chunking. So that's why it's called an agent, and this AI is the agent which does this part for you. So yeah, this is an image of semantic chunking, like I said. So it takes the cosine distance between subsequential sentences, that how similar each sentences are to each other, and depending on that, you just divide it. So if there's a context switch, you just make it into another chunk. So you have all of these indexes of sentences, and then you just divide it into 17 chunks total. All right. So like I said, there's a lot of scope for the research of RAGs, right? RAG actually came a while ago. I was basically some naive RAG. It's just the user and query. Like, you start with it and then you're retrieving it. And the documents or like whatever kind of data, you just index it, and then you, depending on the query, you retrieve whatever documents or whatever content you want from that. And then once you retrieve it, you create this prompt and you give it to this frozen LLM. The frozen LLM is something which doesn't have access to all of these documents, right? So you give that prompt to this augmented prompt, which is using this retrieved data, and you just get the output. And that's a very simple, naive RAG. And there are more advanced racks, but let's just look into a simple thing here. So you just have the query, and then there are several things like query routing, query rewriting, query expansion, and even here there's a lot of scope into optimizing this. So if you have a really good query rewriting, maybe your query wasn't really good enough to retrieve the exact kind of data what you want from the uh, what you want from the documents, or like whatever data you're asking it. So you probably need to change the user query a little bit. You need to tune it more. And this is also something which you can model using AI, as in if you evaluate the entire pipeline in the end and you see that your query, like your query rewriting is not good enough, maybe you change it and then you have a better output in the end. So you just use that here. So you just keep tuning this too, so that it gets um, to writing good queries and all. So this is an additional optimization that you add here. And there is also post retrieval, right? So there is re-ranking once you retrieve it, and maybe let's say it's just uh, ranked on something like, okay, point 0.6, point 0.4. So this is rank 1, rank 2, rank 3, because this is a most similar. Okay, this is a similarity score. So higher similarity score is better. Okay, so you have these three, but maybe actually this is more valuable than this. So this re-ranking algorithm, what it does is it just ranks it accordingly. And this something else is summary. So if you retrieve it like a huge chunk, maybe or several chunks together, maybe you don't want to pass all of that together either. So you want to pre-process it in the sense that you just summarize all of that using an agent, using an AI, using the large language model maybe, and you summarize it. And you keep all of it together. So basically this is a post processing. So you just don't give the raw data back to into the prompt, but rather you'll do some kind of um, post processing. So even here it's like slightly simplified. There is, we just added these two steps, but there are even more optimizations what we can do here. All right. And once you have that done, you just add it back to the prompt, whatever you processed from the retrieved data, you give it back to the frozen LM and you get the output. And this is a bit more advanced because you have all of these extra elements here. There is even things called modular RAG, which is even more complicated. And if you look at the RAG landscape, even there is even more things. As it's an ever evolving field with a lot of branches. And there's just a simple thing, this advanced RAG, and there's the modular RAG where you have just retrieve, re-rank. You do that again and again too. That's in the iteration, um, like this paper, the ITER Redgen paper. There's a lot of ways to do this so that you just tune it. But what I want you to take away from this is the main thing of RAG solving the issue of firstly the context length. Okay, that's one. And the second thing is hallucinations. It just minimizes it. There is the traceability, explainability, as in you know where your data comes from, especially in sensitive areas. Let's say I gave you the example of a medical thing, and if the doctor wants to search something up using a large language model, if you just ask ChatGPT, it just gives you an answer, and you there's no way you can really verify it unless you just Google it specifically. But you can just trace which document this came from, and you can just go ahead and read it yourselves too. So that's a huge advantage. Yeah, and the other thing is you can integrate it with like real time data or ever changing data using RAG, right? So if it's a frozen LLM, you'll never, if it's a frozen LLM, you won't be able to access new written information. But if you just have a database where new information is just keeping on coming, and then you have this LLM here, when you query it again, you'll have this new data here. And this is why when I talked about vector databases, I said this is very important that the real time data is directly added here. Like in Pinecone, we said there is a cache of a freshness layer, etc. And then when you retrieve it, you can just take it from there too. It's a huge advantage here when you can just directly retrieve data which is just added into the database. And this opens up the horizons of use of LLMs in a lot of applications. Instead of just having a LLM frozen in time with a knowledge cutoff of let's say 2021 and it cannot access anything after that, or it cannot give some new information either. And another huge advantage is domain adaptation. And if you have a specific domains, let's say medical, which we said before, and you can just have a lot of documents of just that, and you can just access that. So you can make the LLM work with a particular domain without much changes to the large language model itself. You don't need to train the large language model with predicting this correct, but rather the model is as good as it is right now with just general language tasks, general understanding, and then it's just getting this additional data. That's it. It's not baked into it. So in fine tuning, whatever information is there is baked into it. But in the case of RAG, it just stays intact. Okay, the LLM stays intact, and we just augment it with another database, and we just give all the data from that. All right, that's it for this introduction video to RAG. In our next video, we'll try to create an RAG system, um, and we'll try to code it up, and then we can see how it works in action in real life. That's it. Thank you. Bye.